So these questions on equilibrium sort of bring together everything we've been talking about. So first of all, we have a cat sleeping on a table. And so from that information, we can tell what type of force we're dealing with. There would be gravitational force or weight pulling down. So you could label this F sub G, or you could label it W. Either one would be correct. And then because the cat is on a table, the table pushes up with normal force pointing up. The cat's not moving, sleeping, and so the forces should be balanced, and they do show to be balanced in here. They have the tick marks. So if there's 70 newtons up, there must also be 70 newtons down. This downward force of 70 newtons here, again, that is the weight of the cat. And so we can use W equals, that's a W, equals M times G. We can use the 70 as our value of W. M is our unknown. We'll assume we're on the Earth since we're not told different. And so that's our value of G. Divide both sides of the equation by 10 and we get 7 kilograms as the mass of our cat. Okay, sometimes we're given the mass, like here, the mass of this box here, we're told is 12 kilograms. And so we can get things into forces by using W equals mg. We can say that the mass is 12, and if we're on Earth, G is 10, and so the weight of our box is 120. All right, so which box is that? Well, gravity is the downward force. The weight force always points down, and so that's going to be this box here. Now, in the previous question, we had one arrow up and one arrow down, and so they were both 70. But in this case, I have 120 newtons down, and then I have two forces that are pulling equally up. And so I can take 120 and divide that by 2 so that there's a total of 120 pointed up. That's how equilibrium would show up here. 60 plus 60 is equal to 120 that points down. All right, these last questions, we have somebody who's standing in the middle of a beam. And on one side, we're told that the beam is supported with 600 newtons of force. If he's in the middle, then there must be another 600 newtons on the other side holding him up. So these are going to be equal in this case because he's in the middle. And if there's 600 up here and 600 up here, that's a total of 1,200 newtons. That's pulling up. That must be balancing 1,200 newtons that's pulling down. So that must be his weight, 1,200 newtons. Now, just because he moves to the side doesn't mean his weight changes. It's still going to be 1,200 newtons pulling down. But when he pushes over to the side, this rope ends up holding up more of his weight. How much more? Well, I can take 1,200 and I can subtract 400 and see that the remaining 800 would have to be in this right-hand box.